If a signal is a linear system, we could know about the slope when you have a value. A first order system is usually a linear system. Now, if a non-linear system, in a non-linear system, the value of x-axis and y-axis does not change as same as in the first order system. So now, if we look at the examples of linear system, it is wave propagation, it is electric circuits, it is electron circuit, it is multiplication by a constant, and all the small propagation in otherwise linear system should be ignored and consider them linear. Now, fidelity, some frequency at input and output is invariance in amplitude. No linear signal by another signal such as complete multiplication. In this lecture, we will discuss about the Fourier decomposition and how it is done. Conversion of a signal into sinusoidals and how a complex signal is a complex signal in form of sinusoidals. Why would we like to convert a decomposition in a signal into a Fourier form? Because complex signals can be represented in form of sinusoidals. Most widely used after impulse decomposition is a Fourier decomposition. Alternative to linearity, as zero real life signals are usually disastrous distortions. What is alternative to it then? If a signal is less distortions or have low anomalies, it should be treated as linear. Superposition can only be applied to the linear system. Lecture 10th, the delta decomposition. In this lecture, we will discuss the delta decomposition and how it works. What is delta? First of all, let us define delta. Delta is a function which has a value of 1 when it is at 0 and 0 whenever it is at some value of else. Whenever we look at the picture like this, where when at point 0 there is a value of 1 unity, it is called a delta function. While impulse response, an impulse response is a response where we find a function by the delta functions, where we find the response by using impulse function that is defined as delta function, impulse at the value of certain values. So let us consider h of 0, and where the delta 0 minus 1, and we find the value of h0 at 1. Then we find the value of h is equal to 1, h of 2, h of 3, and so on. And at the end of the day, we can also get the idea that maximum value of h can be 2 whenever we look at a certain function that exactly in this example has been given a certain value of 2. So max number of n that can yield same output is 2 in the example that we have considered. Now, from lower side, we can say that delta n is equal to 0, so otherwise 0. So we can have maximum value of on lower side up to 0 if we are looking at an example.